Hello and good day everyone. Welcome back to my YouTube channel. This is Sir Marcy, and for today's video, we're going to discuss the second part of our lesson that is all about solving problems involving Pythagorean Theorem. If you're new to my channel, please consider subscribing and hit the notification bell so you'll be updated with my latest videos. Remember that Pythagorean theorem is related to the study of sides of a right-angled triangle. It is also called as Pythagoras theorem, and Pythagorean theorem states that in a right triangle, the length of the hypotenuse squared is equal to first side squared plus second side squared. To make it short, the length of the hypotenuse squared is equal to the square of the two legs. In equation form, we have c squared is equal to a squared plus b squared. C is the hypotenuse, which is the longest side, and a and b there is called the legs. So let's try to solve this problem. Suppose we're going to find the hypotenuse. And remember, hypotenuse is the longest side in a right triangle. Also, take note that hypotenuse is opposite our right angle. So, if we will let 30 feet as our leg A and 10 feet be our leg B, then we're looking for the hypotenuse C. We will apply Pythagorean theorem. Remember that you can only apply Pythagorean theorem in a right triangle. So, Pythagorean theorem formula is c squared is equal to a squared plus b squared. By substitution, the value of a is 30. So we have here 30 feet or 30 squared plus b, which is 10 feet. So that's 10 squared. 30 squared is 30 times 30, and that is equal to 900 plus 10 squared is 10 times 10, and that is 100. So we have here c squared is equal to 900 plus 100, that is equal to 1000. So to find the value or the hypotenuse, we will apply extracting square roots. So here we have c is equal to the square root of 1000. So there are some instances that you will get, we're going to simplify your answer in simplest radical form. And 1000 is not a perfect square, but we can simplify this in simplest radical form. By prime factorization, this is 100 times 10. And this is 10 times 10. So, if we will simplify the square root of 1000 to simplest radical form, so this is equal to 10 square root of 10. And don't forget to write the unit. So the value of c or our hypotenuse here is 10 square root of 10 feet. Alright, let's solve problem number 2. We're going to find the value of x. By examining, we know that 10 here is the hypotenuse, so we will use c. Okay, then 6 would be one of the legs, and let's say we will use a here. Then the one that we're looking for is x. Let's say this is leg B. Now to solve for the legs, we will still use the same method or formula, and that is c squared is equal to a squared plus b squared. C is 10, so we have 10 squared is equal to a, which is 6, so that's 6 squared plus b is x squared. 10 squared is 10 times 10, and that is 100 is equal to 6 times 6, that is 36 plus x squared. Applying subtraction property, we will subtract both sides of the equation by 36. So 100 minus 36, that is 64, is equal to 36 minus 36, that produces 0 pair, and bring down x squared. Since we're looking only for the value of x, we're going to apply extracting square root. So we will extract both sides. So this is square root of 64, that is 8, and square root of x squared is x. So the value of x here, x is equal to 8. So that's how you solve if one of the leg is missing. Alright, let's now move on with our lesson, that is the real-life application of Pythagorean Theorem. Let's say we're going to solve this problem. Joshua lives 8 miles directly south of the school. Mark lives 6 miles directly west of the school. What is the shortest distance between Mark's house and Joshua's house? So this one is an example of Pythagorean Theorem. So first is, let's try to draw the school. So this is the school, and Joshua lives 8 miles directly south of the school. So let's say this is where Joshua lives. Okay, so that is 8 miles directly south. Then Mark lives 6 miles directly west. Okay, the question is, what is the shortest distance between Mark's house and Joshua's house? To solve for that, that is this one. Meaning, we're going to find the hypotenuse, or letter C. And let's say we're going to let 8 miles, or Joshua's house, distance of Joshua's house, to be side A, and this is our side B. So to solve for the hypotenuse, we have c squared is equal to a squared plus b squared. So by substitution, a is 8, so we have 8 squared, plus b is 6, so 6 squared. Then we have 8 squared is 64, plus 6 squared, that is 36. So that's c squared. Then we simplify the equation. We have c squared is equal to 64 plus 36, that is 100. Then applying extracting square root, this is cancelled out. We have c is equal to the square root of 100, and that is 10. So therefore, the shortest distance between Mark's house and Joshua's house is 10 miles. Okay? Let us try to answer problem number 2. The bottom of a ladder must be placed 3 feet from the wall. The ladder is 12 feet long. How far above the ground does the ladder touch? So if we're going to visualize it, suppose this is the wall and this is the ladder. And this is the distance of the base of the wall from the ladder. Okay? So here, the bottom of a ladder must be placed 3 feet from the wall. Meaning this is 3 feet from the wall and the ladder is 12 feet. The question is, how far above the ground does the ladder touch the wall? So that is marked as X. Take note, it will form a right angle. Okay? Now, to solve for this, we're going to again apply Pythagorean Theorem. So 12 feet here is our C. Then X here is our leg A, and 3 feet is our leg B. So by substitution from our formula, C squared is equal to A squared plus B squared. C is 12 squared is equal to A squared, so that is X squared plus 3 squared. So 12 squared is 144 is equal to X squared plus we have here this is 9. So we subtract both sides of the equation by 9. So 144 minus 9, the answer is 135 is equal to X squared. Then we will apply extracting square root. So we're going to get the square root of 135 and square root of x. So notice that 135 is not a perfect square. So we're going to find a factor of 135. Okay? So by prime factorization, we'll have 9 and 15. Then square root of 9 is 3. So we get the square root of these two. Square root of 9 is 3. And then square root of 15, since we don't have square root for 15, so we will just affix square root of 15. Then square root of x squared is x. So therefore, the ladder touched the wall somewhere around 3 square root of 15 feet. So our answer is x is equal to 3 square root of 15 feet. Or that is approximately equal to 11.61 feet. So x is approximately equal to 11.61 feet. Let's try to answer problem number 3. The diagonal of a rectangle is 25 inches. The width is 15 inches. What is the area of a rectangle? First is we have to label first the given rectangle. The diagonal of a rectangle is 25, so this one is 25 inches. And the width is 15 inches. So this is the width, 15. Okay? Then we're looking for the length of the rectangle, which we're going to represent it as x. So 25 inches is the hypotenuse, so this is C, and one of the leg is A. So we're looking for leg B. By using the Pythagorean Theorem formula, that is C squared is equal to A squared plus B squared. C is 25 squared is equal to 15 squared plus x squared. 25 squared is 625 is equal to 15 squared, that is 225 plus x squared. So subtract both sides of the equation by 225. So 625 minus 225, that is equal to 400, is equal to 25 minus 225, that is equal to 0. So that's now 400 is equal to x squared. Extracting the square roots, we will have x is equal to 20. So take note, this is the measure of the length. Okay, so this is 20 inches. But we're looking for the area of a rectangle. And to find the area of a rectangle, that is simply length times the width. Since we already know the measure of the length, that is 20, and the width is 15, then the area is equal to 300 square inches. Okay, so that's how you solve this kind of problem. That's all for now. If you think this video is useful, please consider subscribing and hit the notification bell so you'll be updated with my latest videos. Goodbye!